Hello everybody, this is Vu. We have a night guard to make, so let's get started. This patient here needs a night guard on her lower arch. So we're going to open her case up in MeditLink and we'll go ahead and hit the export button here. I have it set to my downloads folder. Pick a base folder and be consistent about it. The file will open up in the subfolder here of this folder. So it'll underneath this my downloads folder, it'll make a folder called 104.2021EB. We want to keep the mesh format in STL and everything else is fine. We can hit export. Once we do that, I've already done it previously. We'll have a folder here ready to go. The next thing we're going to do is open up D3Splint right here. In a previous video, I talked about the user preferences here and setting those up. Look it up on the YouTube channel. Let's go ahead and proceed with the rest of the workflow. We're going to close this user preferences box and we're going to go ahead and maximize Blender. It'll make your life a lot easier. I'm going to go ahead and hit save to start a Blender file. Blender is the 3D CAD animation. It's like a 3D Swiss Army knife program, but the people at D3 Tool, that would be Kevin Yoder and Patrick Ryan Moore, have created this kind of a really ingenious wizard script that works on top of Blender to make a night guard very easily and very affordably. So we're going to go ahead and click on the folder here. We're going to pick up and we're going to go ahead and title it just Untitled. I never name my Nightcard files. I don't find it very useful. And now we're going to go ahead and proceed down this left column. This is the workflow that they've established. As long as you follow the general workflow up to down, top to bottom, you'll get through. So we've checked not for clinical and auto background. Those are automatically set because of the user preferences we did. We're going to go and click on the mandible and flat plane because that's the kind of night guard I'm doing for this patient. We're going to hit import STL model and we will pick the lower jaw, hold down the shift button and click the upper jaw. Then we'll click import STL here on the side. You'll notice that the model is gigantic. So the first thing you need to do is use your middle mouse wheel and spin it, turn it downwards to shrink the model down. The other use for the middle button is if you hold it down, it will rotate things. That's very, very heavily used in Blender. Blender is very left button happy. The translate feature is done by holding down shift and moving the model left to right. Okay, shift and middle button will move your model left to right or up and down. I call that translation. Remember, the middle button alone will rotate. And the right button is used mainly to delete and the left button is used mainly to select. Let's go ahead and click on the set splint model. Now remember, we picked mandible here, so we need to be consistent. Pick mandible here. Click opposing, set opposing, and click the opposite. So that'll be the maxilla. If you were to do the more common maxilla flat plane appliance, then you would just do the opposite of what I did. We're going to set landmarks, and that's going to be the same regardless of what kind of splint you pick. I'm using the middle mouse button again to rotate. Get used to it. You'll be using that middle mouse button a lot. I'd even go as far to say is find a mouse with a very comfortable middle button if you're going to be doing this a lot. Trust me, it comes in very, very handy. We're going to use our left button now as a select to select the right molar and now the left. So remember, right, left, and incisal. These instructions are right here in the upper right. If you don't like something, you can right click to get rid of it. That's universal in D3Splint. And then what we can do is we can go ahead and click on the midline right there, and that will make a rough midline. Now when you click these 3 points, it created a triangle, and that triangle creates a plane, the occlusal plane as a matter of fact. And then the midline point kind of centers the model on that plane. And when we hit finish, you'll see that it puts it all into a virtual articulator. and it's going to use that as a basis to calculate the excursive and protrusive movements. The next thing we're going to do is go down the line, and we're going to ignore the articulating values. We're going to click check clearance first. And we're going to set the clearance at 1.75 by default as a fine place to start. We're going to hit OK. And what you're going to see in this patient is that there are a bunch of red marks, which means that we didn't open her enough in centric relation to accommodate the minimum thickness of the night guard. So what we're going to do is hit the change pin setting button here on the left, and we're going to go ahead and open it up. You can open it up just 0.5 at a time, or you can hit it again, and changing this increases the pin by 0.5. It doesn't set the pin to 0.5, it adds 0.5 to it each time. Okay, so we're going to keep on doing this until the points disappear, until we're just green. Okay, so we're at just green on the right, on the patient's left, I'm sorry. All right, patient's right. And we still have a red mark on the patient's left. So what we're going to do is change the pin setting again, 1 more ½ millimeter, and there we're down to green, and we're down to green. So we're good now. We're going to go ahead and skip recover mounting. We're going to click on the survey model next. And this is going to determine the path of draw. Now, if you set your occlusal plane properly in that previous step, this should look fairly good. We're going to go, I personally like to rotate it up a little bit with the middle button and hit capture view. What that's going to do is freeze the undercuts at the path of draw. This black line that you see coming out of the model, that's the path of draw. This is the path that the night guard will most easily come in and out of the patient. So you want to use a little common sense here and make sure that it's not too far to the left, right, front, or back. Otherwise, the patient won't be able to put it on. We're going to go ahead and use the tweak anterior and posterior button here. I'll show it to you on the side here. When you hit tweak anterior, it's going to move the path of draw forward. If you hit tweak posterior, it's going to move the path of draw backwards. And so when we move it back to the side again, look what it does to the undercut. When I hit anterior, it's moving our path of draw forward, which moves that survey line or that undercut area further down. When we hit posterior, it's going to move that undercut area back up because it's tipping the path of draw. Now, no patient put on a night guard with this path of draw. You have to have something somewhat reasonable. In a lower night guard situation, I typically want to see the undercut be about 2 or 3 millimeters, 2 millimeters from the margin of the night guard. So if the night guard is going to be all the way at the gum line for my lowers, I want to have this undercut area within about 2 millimeters of the gingival margin. That's going to make a little more sense the more you do it. On the inside, I always check the linguals on a lower. On an upper, I will check the buccal posteriors. But I'm looking for undercuts. I want to make sure I have undercuts, and I want to make sure they're balanced. This lady does not have a lot of undercuts. This is going to be difficult. So we're going to go ahead and hit commit now. And now we're going to go ahead, we're going to skip paint selected undercut. We'll save that for when you're a little bit more advanced. We're going to hit refractory model next. And the refractory model puts up settings that we had set in the user preferences previously. Now, once you have a setting that works, I advise you to write it down somewhere, because in case something happens or someone clicks on something accidentally, you'll know to come back to it. So 0.12 and 0.06 are what work for my printer and the resin that I use, Sprint Ray Nightcard Flex. It will vary from printer to printer and also depending on what resin you're using, so bear that in mind. And we hit OK, and this is one of the more slower aspects of the design process. On most computers, that process would, hitting refractory model will take about 10, maybe even 20 or 30 seconds for it to crunch through those calculations. I'm using a fairly fast computer to record this, and so it kind of goes by. Expect yours, expect or be surprised if yours takes a little longer. What a refractory model is the lower jaw with the spacer added all the way around, and then the undercuts blocked out along the path of draw. That's going to allow the nightguard to engage just the right amount you want and no more, no less. So the refractory model is very important. We'll use it at the very end to carve out the intaglio of the nightguard. So our next step is to mark the splint outline. D3Splint basically designs the nightguard in 2 steps. The first step here that we're going to work on is the first part of the nightguard that we're going to work on is the intaglio part, the part that engages with the teeth. And so now we're going to mark the margin of the nightguard. We're using our left button to go around, and it's okay to get it over the gum tissue. This is in a bleaching tray. What will happen is it will float over the gum by the amount of spacer you set. You notice that red line, it solved itself. If it doesn't solve itself, then what you need to do is, let's say we have that red segment there. You click here and then click another line. Click on either side of your gap, and you can fix it that way. Okay. Now, if you find a place that you don't like let's say, oops, I made a mistake here, use the right button to delete it. Use the left button to click on where you want to start again, and then move your way around. Now, this is how I typically design my lower night guards, with a very low margin. On a upper night guard, we're going to get a little closer to the incisal edge to reduce the patient's lip bulk. But on a lower, I'm not as concerned about that. I'm more concerned about getting enough mechanical retention for the night guard to stay. You'll notice I went from 2 clicks to just 1 click per tooth. I would advise you to do 2 or 3 clicks per tooth when you're first starting like this. You'll get into a little bit less trouble. That was a little force of habit there kicking in. I forgot I need to go a little bit slower when we're first starting out. For instance, here we can click a couple points per teeth. The less guesswork you give Blender, the less likely you'll get weird margins jumping across and through the teeth or something like that. Now, here's something interesting. When we have this green dot here and we hover our mouse, it'll suggest what will happen if we clicked at this point. So if we click here, what it's doing is telling me that I'll join the line at this point, which is what we want to do. We're all done. So now we're going to go ahead and hit next. And it's going to ask us to pick the interior region of the splint. I'm going to go ahead and click here, and that's going to turn that interior region of the splint all one color. And now next. Confirm that it was successful. Sure. I don't think I've ever not confirmed it was successful. Now we're going to draw the second part of the night guard. That's the wax rim. The first part was the shell. We just drew the margin of the shell. It's kind of like a sucked down bleaching tray, so to speak, that forms the intaglio. Now the second part of it is the wax rim. That's the upper part of the night guard that the opposing teeth are going to bite on. And so we're going to draw the boundaries of that with the curves. So the maxillary curve is going to be bound by the buccal cusps of the upper teeth. When we get to the incisal edges, we can go ahead and click like this. Broadly speaking, we're going to just click the molars. If you get a little bit more ambitious, you can skip cusps. Now we're going to go to the mandibular. Now for the mandibular, we're going to typically go into the middle of the central groove, and as we get towards the front, we're going to fade into just behind the incisal edges a bit. And this is going to form the pad on which our opposing teeth will touch. In D3Splint, that's called a wax rim. So we're going to go and click through our central grooves. As we get to here, we're going to gradually fade it closer to the lingual. The reason we do that, I used to do these a little bit more to the lingual. What will happen is you'll get a shelf behind the incisors, and it's really irritating to the patient's tongue. They'll basically get their tongue stuck under this shelf lingual to the incisor area, and so I want to minimize that shelf by drawing that anterior portion of the curve a little bit more buccal. So we have these curves nice and drawn now. We're going to go ahead and hit curves only. That'll help you to visualize where the wax rim is going to go. We see we got a weird point here on the orange one. Oh, that's because my mouse was on it. Sorry. If you like or don't like something, or you had something weird happen, you can grab a dot at this point and adjust it, independent of the teeth. When you were in these first two modes, it would try to hug teeth. And sometimes that works, but sometimes you have a tooth that is malpositioned or something, and you don't want it to, or the software just won't let you put a dot where you want it to. This is your opportunity to change that. You can also use the right mouse button to delete points. I don't suggest that. I suggest you just move the ones you have. If you right click and delete, it might work, it might not work. So, but one thing you do want to do is make sure that these outer edges are smooth, because this will become the buckle edge of your night guard, and this becomes the lingual edge of the night guard, this lower curve, this lower magenta curve. Now we'll hit commit. Once we commit, that will immediately tell the software we're done with the marking of our boundaries, and it immediately generates the shell. It has been working on that, doing the math while we were doing all the other steps. And this shell, as I said again, engages the intaglio of the teeth. Now we're going to put the wax rim on it, and that's what our curves draw. So the splint margin affects our shell. Now the curves will find the boundaries of our wax rim, and that's the next click. We're going to hit that there. It's the next button that didn't have a check box. And now we have a splint wax rim. You'll say that's two separate pieces. And you're right. The next button is to fuse them together. Now they're fused. The next thing we need to do is click Remesh Smooth. Now the Remesh filter basically lightly puffs this fused model with kind of the equivalent of a flame on a wax denture. Kind of think of it that way. When you flame back in dental school, you did a little pocket torch flame and it smoothed the denture a little bit. The more iterations you do here, they call them smooth iterations. The more times you run the filter, the smoother it gets. In practice, I would like to do it 100 times, but the software only lets you do it 50 times per request. And so I'm going to hit 50 here, and you'll see here it'll smooth it down a good amount, but we're going to keep going. 50. And it still doesn't look good to you, you can do 50 more. There's really not a limit to this. I will say that what will happen as you keep doing this is that the boundaries of your wax rim will start to get rounder and rounder, and you may create some issues. So you do want to have it smooth, but balance that with moderation. Just be moderate about it. Do as little as is required to do the job. Now we're going to skip a couple things here. We're not going to block out large cavities. That hasn't happened with me yet. I don't usually correct to minimum thickness. That hasn't been an issue with the new Nightcard resins. We're going to mark posterior contacts. And now we're back to the opposing arch. Because we did a mandibular splint, that's the upper. We're going to go ahead and click, especially on green marks. Make sure you click the green marks. We're going to click every cusp tip or any spot that we think will touch. We're going to go through here, click, 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 click. I'm not going to bother with the lingual cusp of, or the cingulum of the canine. That's not even a cusp. But I am going to make sure that the incisal edges are selected. Make sure the tip of the canine is selected, and any posterior cusp tip I'm going to click as well. And this is going to create a plane, a more detailed posterior plane, and of course that green dot as well. It's going to create a more detailed posterior plane. You can see here, if I use my middle button, you can see what it's created here. And it's going to use that to trim off the top of the night guard. So there we have your posterior plane. Remember, the night guard is just a crude wax rim, kind of like when you get a denture back from the lab after the initial impression. You just get this crude pink horseshoe, and you have to adapt it to the patient's bite. Well, that's exactly what we're doing here. We've went ahead and made this posterior plane. We're going to go ahead and do the next checkbox, which is subtract posterior plane. check that, and you'll notice here if we look up, if you look, use your middle button and look, it has subtracted that posterior plane. We're going to go ahead and subtract the functional surfaces here. We background process those functional surfaces, so it'll just subtract them, but since you've probably never seen that before, I'll show you what that actually does. You can see here it was already done in the background while we were doing the other steps. We're going to go ahead and click it here, and you'll see what that actually looks like. It is actually running a simulation of all the possible excursive and protrusive movements using that virtual articulator you saw way back up in the early workflow. Remember all those condylar settings and all those things that we ignored? Well, it's actually using those now to literally run through the motions. Now, we usually want to do that in the background because on a typical computer, that would take about 10 minutes to do. I'm a little spoiled here. I got a nice computer at Costco, and it runs through the simulation pretty quickly. But generally, you want that to run in the background and be already done by the time you get to this point in the workflow. So again, the next checkbox to check is subtract functional surface. Okay, now it's subtracted all those excursive and protrusive movements. The final thing left is to grind MIP. And remember all those dots we made? It's going to grind them off. And there we go. So now we have our Nightcard. It looks a little bit jaggedy at the top now. So we're going to use our old friend again, Remesh Smooth. And we're not going to run it 50 times again, or 100 times even. We're going to run it maybe 10 to 20 times. And my rationale for this is because what the Remesh Smooth filter does is it smooths things out by averaging them out. So high points get a little lower and low points get a little higher. And it's the low points you're a little worried about because all this, especially think of this area right here, this low point right here is going to get averaged up a little bit as you run more and more remeshes. So if we were to run 50 remeshes on this, I'll go ahead and do it for the sake of argument. You'll see here, that's going to be a high spot now because it filled it all in. It overdid it. So I'm going to undo that with Control Z. And I'm going to go ahead and hit Remesh Smooth again. But this time I'm only going to run it about 15 times. That's my usual go-to number there. And if you don't like it, you can, if you do too much, you can hit Control Z like I just did. Or you can just always run a few more iterations. You could do it 10, 5, 20 iterations at a time until you're happy with the result. Again, be judicious with it. The more remeshes iterations you do there, the more likely you'll create a high spot. But balance that with doing too little and having a jaggedy, rough, ugly model, Nightcard. So everything in moderation. All right, so let's go ahead and let's go to the next phase of our Nightcard design. We're going to go ahead and skip finalize the splint because we've got one little detour we're going to make, and that's to emboss the name of it on there. Typically, when we print Nightcards in my office, we're printing more than one. I joke with my assistant that we want to get as many people on the bus before the bus leaves as possible. The metaphor being that, printing a Nightcard involves loading resin and washing and post-curing. You want to have as many Nightcards in the batch as possible for efficiency. Well, the downside of having multiple Nightcards, more than 2, 4, 6 Nightcards in a batch, is that you have to know whose Nightcard is whose. And so one easy way to do that is to emboss the patient's name on it. So we're scrolling down all the way to the bottom. We're going to take a little detour before we finalize this model, and we're going to type in the patient's name. My patient's name is E. Bishop. I don't think she'll mind me letting out, her last name anyway. You'll notice the text depth is set to 0.5 millimeters. That's plenty. You don't want it sticking out any more than that. You don't want it sticking any less. We're going to hit Stencil, and this is going to create a stencil tool similar to the one that you may have seen in Blue Sky Plan. If not, this is it. So you left click once to start it, and you can make it huge or small, but you're basically setting the size and the angle of it. Now, if you don't like the position at this point, don't worry. You can change it. If you don't like this at all, just hit Escape and you're back out. Hit Stencil label again and click, and then you can remake your size. If for some reason you wanted it at a different position, you then use your middle mouse button to rotate the model, or shift middle button to translate the model to put it in a different space. I like it back here by the right molar typically, but if you are a left, if you feel like doing it on the left, just use your middle mouse or your middle mouse to rotate it. Use shift middle button to translate it, and there you can have it on the left side as well. Our office would feel weird doing that, kind of like a left-handed dental chair, but enough about my life. Yeah, I have a wonderful hygienist. She's left-handed, my staff. We love her, but yeah, it was a little bit of adjustment. I won't lie, and it's weird, you know, that kind of brought that up. But let's go ahead, back to the workflow. We're going to go ahead and hit the enter button, and the enter button will go ahead and tack cure. Let's put it that way. It'll tack the 3D version of the label on there. Now, it's not actually part of the model yet. It's just kind of floating on it like a vinyl sticker. What we need to do now is mathematically combine it. We call it a Boolean. We want to do a Boolean combine and merge this 3D letters, these 3D letters that are, you know, melted onto it right now into one piece. So we're going to go ahead and hit the emboss all labels. Pick the default options and hit OK. And what that will do is now make it as one part thing. And maybe if you're keen-eyed, you'll notice that there are no cutouts for teeth, and this Nightcard would not fit the patient, and you'd be absolutely correct on that. So what we're going to do next, the last thing we're going to do is finalize our Nightcard. So we're going to scroll back up to this here. This is where we can add our print raft. That's probably a subject for a different video. I'm going to go ahead in this case. I'm not going to add a print raft. I'm going to finalize the splint. And what finalizing the splint will do is it will go ahead and subtract the refractory model that we had made earlier. Remember that green one with the undercuts blocked out? It's going to and the spacer added in. It's going to subtract those from the bottom of this Nightcard so that our patient can put it on. So we're going to hit the finalize the splint button, hit OK, and then wait for it to solve it. And you'll see there, no more teeth. Fantastic. Now the final step is to export the Splint STL. We're in the same folder that our models are in, which is great. I'm going to type in, just for ease of my workflow, we're going to type in E Bishop, Nightguard, and then STL. And then the file is saved, and our next step will be to put it in Blender. Oh, one more thing before you save. Entering doesn't actually save it. You have to click Export Splint STL here in the right, and now it is saved. One other thing you may want to do is save the Blender file. You can hit save at this point here, file save, and that saves the Blender file too. So now we can come back to this if we need to. I'm going to go ahead and close this file, and on the next video, we will show you how to put this all in the slicer for printing. Thanks for watching.